Good morning, guys. We're going to do 5.5. Make sure you put the notes in your notebook. And if you will just have about 3 of the examples done, I would really appreciate it. Number 1, 2, and 4 would be great, but I am going to do number 3 just to make sure. So today your objective is to define properties of polynomial functions. Here are the following notes. Please have this in your notebook if you don't have it. A relative or local maximum is a high point on the graph, but is not the highest point. A relative local minimum is the low point in the graph, but not the lowest. Absolute maximum is the highest point on the graph, and absolute minimum is the lowest point on the graph. So if you will have a graph that's drawing like this, okay, here's A, B, C, D, E, and F. So your local relative maximum would be B and D. Your local minimum would be C and E. See how they're the low point, but not the lowest. The absolute maximum would be your F, and the absolute minimum would be your A. So that's just an example of what those words mean. All right, so write this down. Pause if you have to copy all that down. All right, let's look at example 1. Okay, so if you will see, I'm going to show you some work as well. And if you will round your decimal place 2 decimal places, that would be fabulous. So how many decimal places? We said 2 decimal places. Okay? So round to the nearest hundredth. All right. In my class I had said 1, so I'm okay with that too. But just when you take your test, make sure you read the directions and round carefully. Your domain is from left to right. So since it's left, comma, right, let's look at this graph. How far to the left is this graph starting? It's starting at negative infinity on the x value, going all the way to the right. So another way I can say this is negative infinity to positive infinity, or you can write all real numbers. Okay? Your range goes from your y value. It goes from the lowest, comma, to the highest. So my range here is going to be from negative infinity for my y, all the way to positive infinity, which is the same as all real numbers. Your end behavior, make sure you write carefully. The x coming from negative infinity. What is happening to this graph? It's coming from negative, but it's also going down. And where it's down, down is negative infinity. Okay? On the right-hand side, notice the arrow is going up, but it's actually going to the right, and it's going up. So your limit on the right, the x value is always positive. What's happening to the y? This y is going all the way up to positive. Okay? So there you have your end behavior. You don't have to tell me left and right. I see negative infinity, that tells me left. Positive infinity, that tells me right. Okay. X-intercept. Look where it's crossing the x-axis, right here at 0, 0, okay, and also at 3, 0. But notice this is a bounce. Since it's a bounce, that will be a multiplicity of 2. And we're going to verify that just so you know it, but if not, okay, make sure you find it. But 1, 2, 3. Y-intercept, see how that's a 0? So this here is plus 0. Y-intercept is 0, comma, 0. It's a point. Make sure you write it as a point. Local maximum. Look at your graph. Local maximum is right here, and that's 1, 4. And we're going to show you how to check it on the calculator. Local minimum is 3, 0. That's your local minimum. Absolute max, y is positive. Absolute minimum, y is negative infinity. Okay? All right. So let me show you a way you could have found the x-intercept as well. Here we go. So y equals x cubed minus 6x squared plus 9x. Factor out your x, and so you have x squared minus 6x plus 9. Factor x and x. 2 numbers are multiplied to give you 9, and it's going to add to give you negative 6, negative 3, and negative 3. Set this one equal to 0, so this is 0, 0. Check. See it? Set this one equal to 0, So x plus 3 equals 3. So here it is going to be 3 comma 0. Same thing as that one. Okay? So that's why you have a multiplicity of 2. All right. Now let me show you guys how to double check your local maximum. Okay? Go to your calculator. Go to y equal. So let me show you guys how to type this in. We're going to check. Type in your equation. X raised to the third minus 6x squared plus 9x. Hit graph. Okay? If your graph's all out of wonk, hit zoom 6. Zoom standards. So we're trying to find our maximum right here. Did you guys see it? To do that, hit second calc. You see where it says maximum? Number 4. Go to number 4. Right now, it says left bound. This X and Y down here tells you where your cursor is. So I am trying to find this maximum. Am I to the left? Yes. And push enter. Go up to your maximum. See how it says right bound? Go a few to the right and push enter. And it says guess, push enter again. Guess what it says? Maximum is 1/4. That checked out. Did you guys see it? Repeat the process. You do the same thing. Second calc. Number 3 is your minimum. Okay, so now I'm going to do this one right here. Left bound is my cursor to the left of that. Push enter. Use the left and right. Please don't use the up and down because you're setting boundaries on the left and right. That was my minimum. To the right of it, push enter. See how it says minimum is 3 and 0. And that checks. So that's how you can check your minimum and maximum. Same goes for the x-intercept, okay? So to do your x-intercept, you'll go second calc, number 2. So pretend I'm trying to find that x-intercept. See how it says left bound? Go to the left, enter. Right click over to your x-intercept. See how it says right bound? Go to the right, enter. Guess what it says? 0 is 3, 0. So your x-intercept also checked out. And do the same thing, okay? All right. Please tape number 2 to your table. And let's see what we can find out. Let me see if I can make this a little bit more clear. Perfect. All right. Let's look at our domain. Here's my graph. Okay. All right. So my graph, far left to far right, all real numbers. My range goes from low to high, so I'm going to skip that one. Limit, x coming from negative infinity. Where's y going? To positive. Limit, x going to the right. There's the right side. Where's your y going? Also to the right. And yes, you have to write it separately. Okay? X-intercept, I have no idea what that is. Y-intercept, see negative 2, so y-intercept will be 0, comma, negative 2. Okay? Local maximum, local minimum, don't know. Absolute maximum, y is equal to positive infinity. All right, so next part. All right, let's go ahead and use our calculator to find the other part. You guys ready? Okay. Type in your equation. Go to y equal. I'm going to clear. Type in x raised to the 4th minus 4x raised to the 3rd plus 4x squared minus 2. Okay, you see all that? Hit graph. All right. Now, if you want to zoom in, you could zoom in right here. So I'm going to get a little highlighter just so how I can zoom in. You can zoom in from here. You guys see this? You can zoom in right there if you want to, okay? If you're going to zoom in, go to your your window. You guys see window? X to the left, I'm going to put negative 3. X to the right, 5. Scale, don't worry about that. Y minimum, I'm going to put negative 4. Y maximum, I'm going to put 2. And if you notice, I'm just zooming in. That's all I'm doing is when I'm zooming in. Okay, and I use that box. You see how that looks like that? It's in the box. All right, now I'm going to use that to help me. X-intercept. So how many places do you have for x-intercept? 1, 2. So how many answers are you going to have? Just 2. okay? I'm going to show you why I'm going to let you use the calculator, because if you did grouping, it doesn't work also. All right, second count, x-intercept, same as 0. Number 2, go to your x-intercept, the first one you want to find. This is the one you want to find. Left bound, go to the left. Right click to the x-intercept. Right bound, go to the right, anywhere to the right. Enter. So my x-intercept, first one is negative 0.56, comma 0. You see that right there? Okay. Let me move this over. Let's do the same thing. Ooh, that looks bad. To find the other x-intercept, right here. Second count, number 2. Okay, so if you're struggling, this is what you should do. Now take a look. Left and right, not up and down. Don't use the up and down. Left bound, to the left. There's your x-intercept. Right bound, to the right. I just hit a couple of times. So the other 0 is 2.55, comma, now, do you guys see this number? This is the same as 0, because it's 0.12000000000001. Okay, so just write it as a 0. There you go. There's your x-intercept. And I'm going to go check my relative minimum. Second calc, number 3. You can do this one first, or you can do this one first. The choice is yours. Okay. There's my minimum. All right. Left bound, 2 to the left, maybe 3. Minimum, 2 to the right. So what is my minimum? 6.65, comma 0. Okay. And I'm going to put this down first before I write it. 6.65. Oh, it's got an E. Sorry. Don't worry, 6.6. See how that E negative 7? That's the same as a 0. Sorry. Let me fix that. See this number? E to the negative 7? That's the same as 0. So 0, negative 2. All right, let's go ahead and find the other one also. Okay, this one right here. Second count, minimum, number 3. Okay, let's go find my other minimum. Okay, 2 to the left, minimum, to the right. Enter. What is this one? This one is 2, comma, negative 2. All right. So, I have that information. See how both of them are negative 2? So guess what? They both are absolute minimum. 0, comma, negative 2, and 2, negative 2. And there is no local minimum, because the y-axis value are the same, the y value. All right, now let's go find the local maximum. Second calc, maximum number 4. Let's go to your maximum, relative maximum, right there. Left bound, 2 to the left, maybe 3. To the top, right bound, to the right. Enter. And what is my local maximum? 1 and negative 1. All right, everybody good right there. So, now that I know that, I'm going to find my end behavior. The lowest y value is a negative 2. And negative 2 is part of it. Right here's your lowest y. Go all the way to positive infinity. And there you have number 2. Okay? All right. Let's go to example 3. All right. I'm actually just going to use the graph this time, but you can check it. Okay? Domain, all real numbers. In behavior, on the left is positive infinity. In behavior on the right is also positive infinity. Okay? All right. Y-intercept, negative 4. So 0, comma, negative 4. Absolute maximum is positive infinity. All right. Here we go. X-intercept, right? Yeah. Let's go ahead and go to a calculator. Let's type this in. Type your equation in, just like you see it. Now I'm going to hit zoom 6. So it goes back to my standard, okay? Okay, y equal x raised to the 4th minus 2x squared minus 4. Hit graph. Alright. I am going to zoom in my graph to look like this. You see it right there? So I can see it better. So go to window. Change this to -4. Change this to 5. Y minimum -6. Y maximum at 1. Just so I can see my x and y. There you go. You want to see your x and y axis. Alright. Let's go ahead and find our x-intercept first. Ready? How many should I have? 2. So second calc, 0. And I'm just going to go straight through instead of one at a time. Okay? Watch. There's my x-intercept. Left bound, 2 to the left. Right bound, to the right. Enter. So what is your x-intercept? -1.80, comma 0. Okay? Now we're going to do the minimum. I'm just going to go in that order. Second calc, minimum. There's your minimum. Go to the left. Enter. Minimum. Go to the right. Enter. And what is my minimum? -1, -5. And I'm going to write it in here just in case my other one doesn't work. Okay? Because I don't know if it's a local minimum or it's an absolute minimum. Next part. Second calc, we're going to do the maximum. And I'm just going to go in order. See how I'm just going on my slide? Left bound to the left. Maximum, right bound to the right. So my maximum, see there's that E again. So my maximum is 0, -4. And I know that right there is a local. Okay? Second calc, let's do the other minimum. 3, enter. There's your minimum. To the right of it, enter. 1 and -5. So, they both got the same. And so I'm going to call that one your absolute minimum. And since I know the y is a 5, my range is going to be from -5 to positive infinity. Okay? And I have no local minimum. And you are finished. Oh, wait. I got to go find one more. I should have 2. Let's go find the other one. Second calc, 0. I'm to the left of that. Point to the right of that. Enter. So the other one is 1.8, comma 0. See e to -12? Same as a 0. Alright, so there's your example 3. Let's go to example 4. Alrighty, domain. All real numbers, range, low to high. All real numbers. In behavior on the left, right? It's going towards the negative. In behavior on the right, it's going toward the positive, opposite direction. Alright. X-intercept, 0, 0, 3, comma 0. By the way, you could do it like that, okay? So this is a bounce, and this is 1. Alright. Y-intercept, there's a +0 there, so that's 0, 0. Absolute maximum, y is positive infinity. Absolute minimum, y is negative. Alright, let's go see if we can find our maximum. Okay, relative maximum. Y equal clear. X raised to the third minus 3x squared. Okay, graph. See, I can see everything, so I'm not going to change my graph. Alright, there's your relative max. Second calc, number 4. Left bound. Right bound, enter. So my maximum is at 0, 0. That's your local. Minimum looks like 2, -4. Let's double check. Minimum 3. Enter. -2 and -4. And there you are finished. And there you have it. Okay? So use your calculator. And if you wanted to check the x maximum, the x-intercept right here, this is how you can also check. Y equals x squared. I'll factor out x squared, x minus 3. Set this one equal to 0. So x is equal to 0 with a multiplicity of 2, because that's a square. X minus 3 equals 0, so x is equal to 3. So 0, 0 happens twice. But just based on that, you can have two answers. Okay? All right. Good luck. Let me know if you have any questions, guys.